In a living organism. What is it that, according to the physical theory of hit theory, that a single radiation particle could cause a mutation? And this goes back to the 1930s when this theory was advanced, and it led eventually to, in part, to the isolation of and characterization of DNA as being a sequence of particles, that is DNA bases. So that was the original motivation for mine, going back to the 60s and trying to understand how it was that a single mutation in a single DNA base and this singularity result in a singular organism with unique characters and physical properties. That is, it was inherited. That is, whatever the hit or the event or the bit of information that occurred as a consequence of radiation was amplified to where it influenced the entire organism. Not only influenced it, but determines its fate, because you do have lethal mutations. And so there's a sense here of the necessity to amplify the logic, to amplify the events, to amplify the physical nature of life itself in order for this all to happen. This is the motivation going back to the 1960s or early 70s for this talk. And I've been very doggedly pursuing these ideas now for more than a half a century. And I'm making little progress here and there, but it comes slowly.
Next page.
Yeah. Oh, this Apple system is just. So it's switching screens on me from when I hit the mouse button. So the purpose of this particular presentation is to outline sort of a diagrammic symbolic logic that relate hylomorphic logic. Hylo here just simply means matter. It's a Greek term for matter. Hylomorphic changes in a logic of a novel number system, where the novel number system is the atomic numbers, which I have formalized in a certain sense of graph theory. So the novel number theory that I'm referring to, I call perplex number system, and that's where the notion of perplexification in the first slide came from. So the next part of this is that what are the foundations, the boundaries, and of the organization of these logics grounded in the table of elements, such that each atomic number represents a balanced labeled bipartite graph. So that's my mathematical objective, is to find a logic and a set of relationships developed from the atomic numbers that will lead to a balanced labeled bipartite graph, which in turn then can be amplified from a particular chemical molecule that it represents to the entire behavior of the entire organism. So there has to be a dynamics connected between the notion of a single DNA base and the change of the entire organism. This has to be an amplified logic, and it also has to be an abductive logic in order for it to be amplified within the conservation laws of physics. So that's the limitation there. So the completeness and the soundness of these novel symbolic logics are founded, grounded, and bounded. Just for a little rhythm in the talk, founded, grounded, and bounded as logical particles. Thank you, Ram, for logical particles. And these have to be related to the table of elements. So this is sort of a categorical logic that relates relatives. Each of the atomic numbers is taken as a relative, and you compose them, you associate them, you distribute them, you commute them, you do other activities with these numbers as atomic numbers in order to develop logical systems. So the foundational philosophy then is that combining these logics generate empirical epistemological oh, ontology. So from empirical epistemology, from the knowledge of what's going on, you develop relational ontologies, and correspondingly composing relational ontologies from empirical epistemologies. So this is the tensions here between physics and chemistry that is exposed by the philosophy of combining logics. So the question of what do I really mean by the notion of logical particles? Frankly, Jason was not available, but Ram and I discussed this at some length on Sunday evening, and it really had he really revealed a sort of gap, a hole in my logic of reasoning. And so I have correspondingly responded with this slide, which attempts and I hope succeeds in putting forth the notion of multiple logical notions within the concept of logical particle. And this term, logical particle, comes directly from Solomon Pfeifferman's works on the metaphysics of mathematics. There's serious questions about what Solomon Pfeifferman's objectives were. But anyway, his basic claim was that numbers are necessary prerequisites for mathematics. That mathematics, basically what he's addressing is a question of is set theory adequate to be a foundation for mathematics? And he's a logician by training, and he apparently was not real happy with that aspect of set theory as a foundational issue. Just as I am not that happy with the table of elements, as being, it's the table of elements. It serves as the foundation for chemistry, but it's not well respected among the physical scientists and the mathematicians. So I'm going to speak then about quaternary logics as symbolic logics developed from historical theories of categories, in particular Kant, C.S. Peirce, Rutherford, Einstein, Schrodinger, Pauling, and others who have put together various notions of category theories, some of which are reflected in the mathematics of category theory, which has been something I've studied for some years. So
Jerry,
quaternary logic, pardon?
Jerry, what is the difference between logical particles and the regular word concept?
And what?
Like a concept, like an eigenvalue of cognitive processes.
Yes.
They form in a concept into a word, and what's that difference different from logical particles?
Yeah. So a logical particle has a specific meaning. It has an exact, precise meaning that you can use in various ways. So it is a constituent. Do I want the word constituent? It's necessary to have logical particles to make a proposition. So without a proposition, you don't. so that's would be the basic issue, Jason. A concept is something purely of the mind. This is something that's also in the external, can be in the external world, not necessarily, but it can have a realizability in the external world as a material object. Is that helpful?
Yeah, I'm trying to capture what. Yeah, I see. My perception so far is that you are trying to be definitely more precise, so disallow any kind of ambiguity in the regular words or concept, like because the formation of a concept, a formation of a number within our brain is a long-term object of cyberneticians, so to speak. So hence Folks call it a token of eigenvalue.
Yes, yes. It is possible to have an eigenvalue that is a logical particle, where eigenvalue is taken to be self-identity. So an eigenvalue, eigen means own. It's its own value in German, okay? And so that this, as it's used in linear algebra, an eigenvalue is a necessary term in relationship to the other eigenvalues of the solution to the set of equations, or of the matrix.
Stable point. Stable point.
Yeah, it could be a stable point. It may not be, but that's another aspect of mathematics. But does that clarify?
Yeah, please go ahead.
And it will become clearer what I mean. Ram?
Yeah, logical particles in organized
Can't hear you.
sequence. Are the logical particles in a ordered sequence?
Whatever ordered sequence you desire to put them in.
But there is an underlying order. Is that what I'm emphasizing?
Well, it's only a linguistic notion of the order of the alphabet. I mean, in order to have a word, logical particles, you have to have an order of the symbols.
Yeah, so it's like the picture I showed. You know, it's like a model. It could be a sub model leading to a larger model or concept. I think that in my mind, that's how I view it.
Well, most important aspect of it is that it has a particular or peculiar identity to it, which it entails.
Mm-hmm.
So it has an entailable capability. Its meaning is inherited as you use it. It may be changed during inheritance, but it's still meaningful. It's a symbol. But the symbol is being very just like other symbols. The meaning you give to the symbol depends on what sign it is. Okay, so I'll go on from there.
Go ahead. Yeah.
So for human scientific reasoning, a basic notion is that abstract represents. Oh, I can't see my entire screen here. Representing nature can be assigned, arranged, composed, and otherwise massaged by cognitive operations. So the focus here is that logical particles are subject to cognitive operations, which it could include associative, distributive, commutative, and other properties, but it's up to the individual to do so. And so this is what then, in terms of C.S. Peirce's notion of signs and the associated terms of signs, all derived from the notion of Latin word of seems, So seems, as I'm going to use it here, is a mental object. It's a logical particle, maybe a logical particle, but it's a mental object in which you can operate on in terms of associated, distributed, and other mathematical rules, or if you can also have semantic rules to operate on it. And how you interpret external events is in terms of the semiotics of the events and processes. And the processing of seams themselves is through the notion of semiosis, and the associated logics are semiologics that relate seams, semantics, and semiotics all together. And the crucial reason why I focus on this then comes to the notion of one will connect specific scientific taxonomies to specific sentential syntax. And I note here from a logical side of notion that the sense of logical syntax, or as used in languages, comes from the same root word of taxonomies. So that a taxonomy imposes syntax on sentences. And this could be propositional sentences, for example, or there could be mathematical sentences, or there could be chemical sentences, or they could be other linguistic sentences. So the relative meanings then of logical particles, we can think in terms of how we associate logical particles in terms of encoding or encircling categories, and in terms of how they're used in various linguistic grammars in that context. So before I leave this slide, is there any questions with regard to the meaning here? Ram, is this helpful to you?
Yeah. I was going to bring up the discussion that we had from Gregory Bateson.
I can't hear you.
The discussion that we had about Gregory Bateson, that is, the map is not the territory. In other words, it's the sign is the reality is more important than the representation of the reality. The sign is the representation, whereas the reality is what is important. And that's what Greg Bateson's famous quotation, right? Map is not the territory. I thought this somehow relates to that, but we can get back to it later. I don't want to digress.
Yeah, well, definitely the question is here of one of representation. Right. If you're going to use the term logical particles, what do you intend to represent in the mathematics? And so this is very closely related to the work of Robert Rosen in that context.
Okay.
So this is a slide from January, and what I'm going to discuss today is an extension of this slide. And basically my concern is biological in nature. And I'm really, I've spent my career in public health. So my real concern is what's going on from various, for example, environmental exposures as causative agents in human disease, which is the initial motivation going back to the 1970s. So we want a system of logic or systems of logic which relate the part to the wholes, that sort of relate emergence, that in this case, we want to start with the notion of atoms and atomicity as being the characteristics of atoms. And the notion of decomposition, starting on the far left of the slide, decomposition of the whole into parts. One could call this distribution of the parts within the whole, but I would not use that language here. I would rather call it a partitioning of the whole into parts, such that you separate the individual atoms from the totality of the organism. So this is a massive, and I don't want to use the term reduction here because I don't want to reduce it down to individual points, but just to logical particles. So I don't want to do a complete reduction. So I call this process on the left-hand side retroduction, just returning back to its original origins as atoms. Analogously, there's a process of composition in which the individual atoms are associated and now distributed into molecules. Molecules are distributed into cells. Cells are distributed into organisms as a whole, and including the distribution within the brain. So that the operations of the brain then is a composition from atoms. And the processes, Whiteheadian processes in the brain, are a consequence, a logical consequence following from the compositional nature of the atoms. If you might find this from a philosophical or mathematical point of view difficult to comprehend, I would remind you that various drugs, which are individual molecules with identity, have a fantastic importance on brain operations. So certainly there's no, the retroduction to molecules still has a major impact on the operations of the brain. And so this issue of scaling, I call this issue of composition then one of the scaling of symbols, the scaling of logical particles from atoms to anatomy. So that's the intention of the left-hand side of this diagram. The question then from a scientific point of view, from a cybernetic point of view, from a systems point of view, is how do we describe languages to the left-hand side of the screen, to the up arrows and the down arrows? What's the role of language in assessing the meanings of atoms to anatomy? So from atoms to anatomy, we'd like to have some descriptive meaning, ascriptive meaning that relates the units, the integers, the numbers, the permutation groups, and the space groups. Now, in terms of eigenvalues, Jason, space groups are composed from eigenvalues. So the notion of composition of categories, or units of space groups is one of the use of eigenvalues. And this is where there is a very, very profound and deep distinction between my use or notion of group theory than a rather noted quantum theorist who often comes to Club of Remy meetings. So the distinction here is that the going down the column now under systems descriptions, names, sentences, and grammars generate permutation groups of numbers, of atomic numbers, as integers and of units of meaning. So that under systems description, units of meanings are logical particles, which include the atomic numbers as numbers, which are formed into permutation groups, which then can be related to or composed into space groups. And that these space groups can have names, and they can have a taxonomy and a syntax in their sentences that are arranged by the grammars of the language in such a way that the terms of the propositions are the chemical elements or compositions of them or constituents of them, and these in terms generate cells, species, and organisms. So I've tried to make a single sentence from symbol ascriptions that relate the up arrows and down arrows. Now the question becomes, what sort of formal transformations are needed in order to make propositional sentences that relate these formal transformations? And all of this revolves around transformations of meaning, so that the transformations of meaning, transformations of the logical particles, depend on the associativity of the symbols into permutation groups. And from there, the mathematics unfolds. So I've summarized the hour-long discussion from January. I'll pause for questions or comments.
I'm thinking the difference between sands and stone and something in between, like the concrete, concrete powder that Romans invented. So on the one hand, you have atoms like sands. On the other side, you have a bigger object or autonomy of a whole, like a stone. So those are the difference is that the stone contains a lot of bonds, okay, the chemical stuff to make sense material into a solid, big chunk. Now I'm getting your concept of a logic particle is pretty similar, like the role of the concrete, the mixture of the magic compound that bind the science together into a huge piece. Is that the right direction? And I'm getting what you are trying to.
Yes, you have one extreme view of that usage, where one wants to fix the meaning of the logical particle into a fixed set of relationships, such that the concrete stone is formed, and that this notion of transformation is particularly generalizable for all logical particles that are in the stone. So behind, as I understand what you said, you're seeking in your mind some sort of uniform interpretation of composition. Did I capture what you wanted to say?
Yeah. This is something like a good metaphor of. I mean, your current talk is pretty abstract. I was trying to come up with a concrete sample.
Yes.
I mean, to handle it.
Well, I think from a biological perspective, if you want to try and get a concrete mental image in your mind, that is, if you want to have some seams from which you can then manipulate around, then you need to consider well, you need to consider first the general scheme of going from atoms to molecules to cells to organs, etc., as being very, very specific organization of the parts of the whole. And that so that not logical particle as used in the sense of presented here in terms of hylomorphisms rather than homomorphisms, if I can make that distinction, is that the individuality of the logical particle is preserved all the way up, so that the nature and properties of the atom, if it's a gold atom, it's the same, it's preserved whether it's in a chunk of gold or whether it's being used for imaging or transmission of information or whatever. So there's a logical particle has this capability of entailing larger things and transferring its properties to larger things. So the accessibility or the description of perhaps the simplest way is description of a family. Each of the individual members of the family has its own identity, but the family as a whole is something that is composed of all of those identities, plus the property of being a family, of having entailments from the parents to each of the child. Is that helpful?
Yeah.
So I could, Jerry, Actually, I could use this slide in my talk.
Thank you. Thank you.
Yeah, because you know, on the left side is the distributive, and the next to it is associative processing from whole to the parts. Right on the right hand side, you have ontological units, or logical particles, you call, and their relationships, what they produce, right?
Right.
So you can apply this to the matter or the information. I think it'll hold.
I sure hope so, because that's my premise. That's the premise involved.
The fact that we all come from different angles and end up with the same conclusion, I think that's that's triangulation, right?
Okay, next slide. So now we need, Jason, this may help you in pursuing that, and it may help Lauren also in his views. So somehow, as we ascend through associativity, we have to balance the scales and scopes of the semiologic reasoning. And Jason, I think this is precisely the question that you were addressing in your comment, or at least I hope so. So I really like the notion of the sounds, and that in formal logics, they talk about soundness and completeness. And so I'm sort of making a pun on the silliness of formal logics. Grounds, bounds, founds, rounds, and sounds seem to sort of capture the mindset of formal logicians. And I would distinguish such formal logicians or logical reasonings in terms of the different sciences and the silos of meaning that come up from alternative usages of symbols, and why people like biochemists have a difficult time speaking with physicists and mathematicians, and correspondingly physicians who practice medicine have a very tough time grasping the nature of chemistry, and most of them would prefer not to deal much with mathematics. So across the intellectual spectrum, there are very different uses of language and terms of meaning. And this is the interpretation of signs is different. And so this differential determination of signs is what I'm trying to capture in terms of the balance points here, where starting on the lower left side of the slide, we have bounds and grounds for number theory, for example, and the association with the language of mathematics that gives both the round here, R for round is talking about the circumscription of the meaning of mathematics. So round is the sense of a circular logic that is closed on itself for mathematics. And this circular logic is the language of mathematics. And as I said, in the formal logics at this point, the crucial source of consistency in formal logic is the notion of soundness. So soundness and completeness are represented in terms of R and S on the lower left side, where the boundaries and the grounding of mathematics is given in terms of number theory and the relationships among numbers, which are then associated into higher mathematical structures that typically are arranged in such fashion as sets, groups, vector spaces, topologies, categories. There's dozens of such different hierarchical organizations of mathematical terminology. But the grounding all goes back to quantification of numbers and the ordered sequence of integers, which then associate the individual. And this, of course, leads into model theory, which Osmond talked about as a basis for the soundness of teaching as a teaching tool to help students see the relationships involved with the logic of the sciences. I want to go beyond the logic of the sciences and also to the logic of languages themselves. So with that detailed description of mathematics and with relation to grounding, rounding, founding, rounding, sounding, da 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 da, we'll make a tune out of that eventually. Physics basically mimics mathematics in their style of reasoning, and they are very, very successful at it. And actually, the capability of this group gathering together today from 3 different states in the United States, 4 different states, actually, no, 3, and as well as our guest from Holland, is really quite, and Canada. So it's all enabled by the success of physics and mathematics in establishing communication systems, in the transfer of information, etc. Just want to ensure that my physicist colleagues don't feel obligated to feel offended by this category, because what I'm going to say now may well be offensive to some of them. Okay, I want to be prepared for that. So the science of chemistry has a different history behind it. And this history of the science of chemistry was one of making recipes, and particularly the success of making recipes for doing things in the world and actually accomplishing things in the world was related to the symbol system that eventually evolved into chemistry. The initial recipes that were very successful in promoting human evolution and emergence were, first of all, the founding of metals, so that foundries developed to make, for example, first start with note that gold and silver occur as pure metals, and you can identify them from vision without further sensory abstractions. So that the 2 symbols for silver and gold, AG and AU, are historical symbols. And of course, the early history depended on the development of smelting. First, that was accidental for tin, which actually would be excreted from rocks upon heating. And then iron became into play later as a distinct method for founding metals. And the separation of metals became important for making coins. And so the foundational notions of preparing pure materials, as well as the massaging of these pure materials into different forms, were the parts of the initial foundation of inorganic chemistry. Organic chemistry had different origins, and it came first from food preservation, and of course, cooking of foods. There was different methods developed for relating cooking methods to the quality of the foods. And of course, that eventually, very early, the history of alcohol goes back to the earliest societies, certainly fermentation processes, chemical processes of fermentation, dated certainly from the year 3000 BC. So that this notion of recipes gradually evolved in terms of human cultures, and got a big shift in around 1800. One, when Lavoisier showed that gases could hydrogen and what were known as hydrogen and oxygen, although allowed to form, could be combined to form water, and in turn, water could be decomposed into hydrogen and oxygen. So this was experimentally demonstrated about 1785 by Lavoisier, and had a profound influence then on the entire development of chemistry, because now he was able to show that not only were organic things composed of particular elements, but that invisible gases were composed of atoms or something equivalent to atoms. And this, again, followed very shortly thereafter, around 1800, when Volta discovered that pure metals could generate electricity. And so the combination of these two things, the invisible gases could be made visible by making water from hydrogen and oxygen, and that invisible electricity could be generated by stacking up different metals to give you an electric current flow, then became the foundation of chemical logic. And the explanation of these became the necessity for the development of logic, of chemistry. And this notion then of using symbols to represent chemical elements is grounded in this early history. Moving quickly then forward to genetics as a necessary language for biology came, I won't discuss this any further, you're all familiar here with DNA and RNA and protein and this metaphor, these scientific languages which are used to describe living organisms as being molecules in themselves and hence of chemical origins. And this in turn then eventually emerged with the practice of medicine as it's done today, where the genetic sequences of individuals become the foundation for, if you would, sophisticated medical practice, and correspondingly the use of drugs in general and toxins in general are associated with the chemical language through the genetic language. So I've spent a bit of time on this grounding, bounding, founding, rounding, and sounding because it is the basis for the differentiation of the logics that have emerged, and the distinction for the scientific logics that are involved. Before I leave this, I hope I've given a quick overview of the history of science. Too much big lapse.
Give us an example on a medicine scale as well. Don't worry about the time. You can have all the time. Medicine.
I mean, there's such a huge number of them. I don't know how to say. I guess let me put it this way: the role of physics and chemistry in the practice of medicine and the consequences of it in this terms of decomposition and composition. And I will go back to a recent incident of the pregnancy of a daughter of a friend of mine. This now goes back about 18 months ago. In a routine screening using physical methods of sonograms, the fetus was shown to lack movement in the legs and perhaps the arms, and that at this stage of the pregnancy, which was about month 7, there the physicians anticipated that they should see movement of particularly the legs and feet of the fetus at that stage, but they detected none. And so this led to a reasoning that there was a malformation of some particular type, that the fetus was not developing normally biochemically, that there was the neural connections necessary to move the feet and legs were not developing properly. There was a temporal development delay, and this had been noticed in other fetuses, in a large group of fetuses actually. So this was then given the language of a syndrome and the delayed neural development being the result of certain genes that were known. And so they repeatedly followed the sonograms. They identified that the parents of the fetus both carried genes that could be related to this syndrome. And they prepared then, they could not estimate the sensitivity of the inheritance of the genes from the parents. They didn't know what the mathematics of the inheritance was, but they did feel that it could be a very mild case of the syndrome, and that it could be very severe. And then, in other words, the child could be born without effectively any mental capacities and have very little chances of survival. Or it could be that it was a very minor delay and that the child would eventually be perfectly normal. So there was this spectrum of interpretations of the genetics of the parents on the nature of the offspring. Okay, from that on, fast forward, the child was born, the birth was normal, the development of the child was quickly ascertained that the child was quite delayed in development, and they actually immediately put the child on oxygen. It turns out its pulmonary capacity was insufficient to process oxygen as a chemical matter, purely chemical matter. So they put him on oxygen. It also, the digestive system was not able to digest food, so the chemistry of development was delayed as well. And long story short, the child is now 6 months old. It's received probably $1 million worth of individual therapy in order to have the whole medical team devoted to its survival during the first 3 months. The child is now at home and appears to be developing fairly normally. Is this adequate integration for you, Jason?
Yeah, more than that. But I have an idea. Maybe, Jerry, you can remake this slide into a list, like with columns of grants, bonds, funds, runs, and songs, and then and on the rows you can put into different examples and different languages in mathematics, physics, chemistry, etc. So make it a long list.
That's
Maybe
that's an excellent suggestion. I'm glad I did it.
Can I add a comment?
Of course.
Yeah. So the cell division, I don't know if it's related. You know, when the cell divides, before it divides, it copies its DNA, right?
Correct.
If it copies the DNA sequentially from one end to another,
one circle to another,
it straightens its DNA, but through some enzymes, and then it starts copying, right?
Right.
If it does it if it starts from one end, copy, to the other end, it'll take 347 days for a cell just to copy its DNA. What do you think it does to overcome this difficulty?
Well,
In reality, it does it in 6 hours.
the cell doesn't know mathematics.
Well, it does parallel processing.
Yeah, no,
Yes.
it depends. So you now get into the question of the energy distribution and how the energy is distributed to reproductive processes, and how if you would, the information content of enzymes, the catalyst, such that the arrangement of atoms is accelerated. But I should go back to a factual question of basic, is that in E. coli, a simple bacterium, it has a circular DNA. That is, it's continuous, a continuous circle. And in under appropriate circumstances, it can reproduce its roughly 1 billion bases in about 15 minutes, because this is the cell division time. So you're talking about a case probably in human cellular systems that you're talking about was the origin of your data.
Yes.
Bacteria.
I see. Okay. So what I'm saying is it took us thousands of years to discover parallel processing. Yet the cell, it did it for so many years. It copied its DNA pieces at the same time,
Yeah. Well, it turns out that Mother Nature is a much better mathematician than we are.
I think so.
It seems like as you're going up this tree, that it becomes more difficult to define things precisely and make precise logical arguments. Is that a fundamental limitation in a desire to try to make definitions more precise?
I want to ask that question as well, in a way that the solidness of your logic particle become softer and softer as you're going up?
Well, in both cases, the question of how should I, as a chemist, interpret the notion of preciseness? How should I interpret the notion of softness? These are, in language, these are terms that are used as antecedents in some sense or another to describe natural processes. But I think the common answer, my intuition is that perhaps the way to communicate this is that the entire logic of chemistry is at the quantum level. So that even though we go into the laboratory and we measure out grams of gold or pounds of iron or tons of steel, or however we want to quantify things in the vernacular language, the entire language of chemistry is at the quanta level. In other words, a logical particle as an atom is one of roughly 10 to the, well, the numbers here become massive. And so a tablespoon of water has 10 to the 23rd molecules in it. And so the starting point for the logic of chemistry is at the level of quanta of atoms. And the atomic numbers specify a particular amount of mass and electricity that is associated with the number. And that is an extremely tiny amount. And so it becomes very difficult for ordinary people who don't know the language of chemistry and the methodologies of chemistry to comprehend how this occurs. And certainly the idea of precision is sort of intrinsic to this. The other side, Lauren, particularly to your question, is that a DNA base is a particular DNA base at a particular location in the DNA molecule in a particular organism. Is that precision or not?
I agree that, okay, whenever I read explanations of chemistry, they always seem to be physics explanations. And so it seems like when we want precision, you go down this order. But people don't stay at that bottom level because it's too complicated, it's too detailed. It's much more useful to go up to a higher level where it's less precise, but it's more immediately useful.
Yes, you're pointing out to the notion of vernacular and in general the absence of educational chemistry, that the general public is so ill-informed about the nature of chemistry that they can't comprehend these arguments.
No, I'm talking about, let's say, the doctor with medicine, as you mentioned, not wanting to go down to the details of genetics and chemistry, but being very well trained at the level of medicine, but being unable to use as precise language because it's at a more general level.
Perfect example. Perfect example. That's why uh, physicians, as such, understand chemistry at quite a deep level because they see the influences of drugs on patients. And they see this every day practically. And then they base their practice on which chemicals they will prescribe for which physiological states. So they have the practice of medicine is based on this intuitive understanding that very small amounts of drugs will change the whole organism.
Yeah, I agree with what you're
Oscar
saying.
told me that he needs to leave earlier, and I don't think we have time for my own presentation. That we're calling for another follow-up session. I think if we do a follow-up session, and Jerry, you can create for us that a long list. Convert this diagram, highly abstract diagram, into a more comprehensible list. Perhaps you can do that. And also you need to face the challenge when you're going down and down to the under quantum level, your particle disappeared. And, and the things disappeared, and all you have are those waves and events going on.
We can talk about
that.
Jason, we can talk about that.
Yes.
Jason, yeah.
But let me go to the next
how about
slide.
The 25th, 2 weeks from today?
No, I can't
okay?
do that. I have another talk scheduled for that week. But how much time has gone on? I don't know.
Later. The next one would be July 2nd.
Okay, that's good.
July 2nd is okay?
Yeah.
Okay with me.
Yeah.
Okay, let's get
Jason,
together on July 2nd.
I gotta leave. I think I need to leave. I enjoyed this conversation very much, and I appreciate you inviting me.
Yeah. Let's get together on July 2nd, Wednesday, to continue this.
Osman, are you in Boston right now?
Yes. So,
okay.
You guys can go for a drink.
I'm in Natick, and I'm here for a couple more days. Then I go to Rochester, New York.
Okay.
I have a home over there too.
I'll send you an email. We can catch up. I need to talk to you, but Jason, I just want to make one statement. You know, if we can take a look at the statement that Hans von Förster made about computing, that kind of ties very nicely together what Osman presented and what Jerry is saying. I have that as a PowerPoint slide. It's just 4 lines. Do you guys want to look at it now or some other time? I have it on the screen right now.
I have one more slide to go. I have only one more slide to go, and I'd like to present it before Osman leaves because it's critical to his understanding.
Thank you. Go ahead.
The question is, how do you make a synthesis of these logics in terms of signs? And this follows from Persian logic. And the question is, what sort of matchings do we do with the interior operations of our mind versus the matching with the external operations of the taxonomy? And this in turn on the right-hand side, now go to the right-hand side and see the upward arrow going from natural language and the formation of terms. Now we have syntagmatics is a linguistic term related directly to syntax and taxonomies as being part of the chemical language. So semantics then is the basis for the taking apart, the disassembly, the disconnections, the separations, and the partitions to form the taxonomy of the sciences. To form the taxonomy of the sciences. That's a big mouthful. Big mouthful. On the left-hand side, you have the corresponding mental operations, which mean association or putting together, assembling, arranging, abduction, and then the notion of logical synduction, that is the synthesis of chemicals. So on the left-hand side, all of these assembly operations use a different syntax. And this, Jason, is where the origin of the list of terms you want would come from, is that these individual syntaxes would then be arranged according to semiotics, the semiologics of signs in order to form the syntagmatics of the language. And this bottom row here from syntax to semiologics to syntagmatics is the origin of chemical terminology. And so after you have disassociated a molecule or any collection of logical particles into the individual atoms, then what you do is you form a permutation group from these atoms. That would be the molecular weight or the molecular number. That molecular number would contain the names of all of the constituents. The names of all the constituents will be patched together to give you the name of the molecule or the name of the object. And that's what syntagmatics is about in terms of the synthesis of the terminologies of the logic that I'm talking about. That's where the origin of the term quaternary comes from. That is, we have premises and conclusions on both the left-hand side and the right-hand side. So we have two pairs, which gives us four. So that's where the origin of quaternary logics come from. And this is the basis then of computations. And here the critical argument for Jason, from your perspective, is that the natural computations that are done on the right-hand side of this must be done on the mental computations on the left-hand side, so that the atomic numbers that form the permutation group become the basis for associating and distributing the logical particles. And these in turn generate the logical languages. So this is the sort of synthesis that Ram and I were talking about on Sunday night. I think he grasped part of it at that point, but not all of it. Gerard has heard this story from various perspectives over 20 years, and he's smiling. And he actually, I had several very important conversations with Gerard that contributed substantially to the development of this line of reasoning. So I'll stop there because time is short, and I appreciate the time, Jason. I appreciate your efforts.
Gerard, what's your response?
I like to see the rest, to hear the rest of your talk. So I will be there.
I'm giving this a different version of this on Friday to the it's an AI conference on philosophy of AI and logics. It's a computer science group that's interesting.
Yes, I find it very interesting.
Could you send us the link if the URL that your talk next one? But we decided to get together on July 2nd as well here, right?
Okay.
Yeah,
Okay.
yeah, that's a tentative date from my point. I have to look at what else is going on. I may have a surgery scheduled. I have to be flexible.
Okay.
Okay.
Okay. So thank you.
Thank you. Great to meet you, all of you. I
Great to
love
meet you also, man. It's your first time. See you next time.
Okay. Thank you all.
Okay. Bye.
Bye. Thank you.
What time is it? Do you want to stop?
Yeah, because he needs to leave at right now. So
Okay.
maybe I think since we scheduled the next one, we can finish now.
Oh,
You have any more questions? Burning one?
No, I just wanted to just say something about what Hans one first said about computing, because that is very relevant to today's discussion. We can discuss it another time. It's just one
Send
slide.
us-
no, I'd be
send
very
us the
interested in what
reference.
you say.
Pardon?
Tell us what we have a few minutes.
Okay.
Yeah.
Wait 1 second. And let me bring it up. Oh, can you stop sharing,
Yes,
Jerry?
yes. Oh. Where's the stop button?
When you go to the share, I think you should be able to stop, right?
Let me try. Jerry, stop sharing. Now you can do your sharing, Ram.
It happened. Okay. Did you do it, Jason?
Yeah, I just figure out how to do that.
Okay.
Okay. Can you see it now? Can you see it?
Yes.
Yeah. Hands
Okay.
from
Yeah,
first.
exactly. Yeah, this is all I wanted to say. It was in fact, when you sent out the meeting discussions request, I had replied to that on March 12th. I just pulled it out of my email. What is interesting is you should really read this one paragraph here. How he defines computing is computing literally means to reflect, to contemplate things in concert without any explicit reference to numerical quantities. Okay. Indeed, I shall use this term in most general sense to indicate any operation, not necessarily numerical, that transforms, modifies, rearranges, or orders observed physical entities. The key point is observed physical entities or objects or representations or symbols. So computation is a very broad definition according to Forster here. So if you use this, you can go in two different ways. You can talk about physical things like what Jerry was talking about, going from atomic mass units and atomic numbers, and then building up chemicals, and then going through the whole life form to be composed of chemicals. But everything goes back to the fundamental atom, right? So the point Forster makes is he proposed to interpret cognitive processes as never-ending recursive processes of computation. So here the word computation is very general, right? You just keep on assembling things. Now, in case of what Osman was presenting was, instead of staying at the physical entity level, he keeps it at concepts level. So which is what we are talking about, the symbols. So this definition captures both the symbols and the physical entities. Never-ending recursive processes of computation gets us there. Now, what is interesting about cybernetics then is cybernetics takes you to the top level to say cybernetics is control and communication. But what do we control? Control is behavior. What is behavior? It comes out of physical matter interacting together. Whereas communication, control and communication is knowledge. Right now we are dealing with concepts and building things out of recursively concepts. So if you take the basic definition of cybernetics and tie it together to Foster's description of computing, you can either keep doing communication and building up recursive sequences, or you can take behavior and keep looking at physical entities and building up recursive sequences. But in biology, what happens is you have to have both, right? I have a body and that needs to be controlled, and I have a mind and thought processes or knowledge that needs to be communicated. So that is the interaction between the mind and the body, control and communication, a never-ending recursive process. So the general definition of cybernetics then is self-organized, reciprocal, control and communication between complementary entities, the complementary entity being body and mind, and the interface between them is the brain. So if you start with such a holistic approach, you can see that today's discussion, both parts kind of fits into the same thing, at least in the way, that's the way I see it. Okay.
If I could comment.
This is from Hans or Hans?
Yeah. Did I spell it wrong?
Hans is the son.
I have no, I don't, it just.
Double check, because.
No, this is published, this is from some of the emails that we were having about Forster. I don't know whether there are two of them, sorry. HPF.
Looks like a Hans, because Hans is his son. So I'm not sure if Hans had done this similar work like this.
No, this is 1973. This is from a conference.
Should be Hans, I guess.
So there should be no one. You're saying there should be no VON? Is that what you're saying? I'm sorry, I don't know the family.
Hans von Forster is the advisor of Stuart Appleby, who doing this BCL laboratory in University of Illinois. Hans is his son. Hans used to, I think Hans is an artist, but this the language you're using here looks like a Hans, originally from Hans.
Well,
anyway, we can figure out the next time.
Okay, I'll check it out.
One comment before because Ram is introducing, giving some interpretations to things that I said that I didn't say. I said nothing about the limitations of the various languages, and I certainly didn't address the question of the nature of computation. I certainly did not address that.
That is why I'm.
Well, I just wish you'd be a little more careful about what you attribute to me saying when I don't really actually say that.
Okay, my interpretation of what you're saying, sorry, I'll take it back. I'm saying you can deal with physical entities and atomic units, or you can talk about symbols and knowledge communication, but both of them are never-ending recursive sequences. That is the point I'm trying to make.
I take it back. Quite well what you said. Okay, it's not a question of what you said. It's who you attributed what to.
No, I don't. Every time I hear you, this is the way I perceive it. I'm sorry. Maybe I'm not able to understand you at all in that case. Okay.
Okay.
Thank you.
Let's see next time.
Okay.
Confirm the place.